Hello and welcome to Empowered Learning. This particular lesson will be on how to use the sum and difference formulas for the basic trig functions sine, cosine, and tangent. So to start off with, we want to quickly review what these particular formulas are, and you should see them on your screen now. And then afterwards, we will go into examples of how they are used along with some of the other previous identities that we've learned. If you have not seen those videos and you want to check them out, please do. There are videos on the Pythagorean and reciprocal identities, as well as the even and odd functions for trig functions videos. All right, so if we look here, we see that the first two of these formulas is how we deal with the sine of the sum of two angles and the sine of the difference of two angles. And so we see the pattern here is that for sine, we have an alternation in between sine and cosine, where the first one is sine A cosine B plus cosine A sine B. And notice that since you're adding two angles, the two terms that are being added on the right side of the equation, they have the same sign. So adding means they have the same sign with the identity part on the other side. For cosine of A minus B, of course, we know that it has to have the same sign. So sine A cosine B is being subtracted from cosine A sine B. And for number 3 and 4, we're looking at cosine of A plus B. And in this case, we see that the other side of the equation, we have a subtraction sign. And we see that the first term has both cosines for each angle, and the second term has both sines. So cosine of A plus B is cosine A cosine B minus sine A sine B. For cosine of A minus B, we have cosine A cosine B plus sine A sine B. So for cosines, we see that the signs change, but for sine, we see that the signs stay the same. And for the last one, tangent of A plus B and tangent of A minus B, we see that just like sine, the signs stay the same in the numerator, but in the denominator, they are the opposite. So we have tan of A plus B is tan of A plus tan of B, all that divided by 1 minus the quantity of tan A times tan B. And tangent of A minus B is tan A minus tan B, all that divided by 1 plus tangent A times tan B. And so now we're going to go ahead and move on to some of the examples. We will be referring back to these particular identities. You should probably write these down and keep them close to you as you're learning these. But eventually, if you use these enough, you should be able to memorize them. So let's go to our first example. All right, so our first example says we want to simplify the following expressions using the sum of difference identities for sine, cosine, and tangent. If we look at this very first one here, you'll see that this sort of resembles one of the cosine identities, but everything's not quite there. So if we let angle A equal 80 and angle B equal 40, then we need to find something that matches up with that. We see that we have a minus 80 here, which is a problem because it doesn't match up with this. And we see we have 50 degrees, which is totally off. But we do notice that 50 degrees is a complementary angle with 40 degrees. So we may be able to use a cofunction identity there to help us out. So let's start with this first one. So we see sine of sine of minus 80 degrees. We know that sine is an odd function. So this could be rewritten as a minus sine of 80 degrees. For the second one, we know that if we do the cofunction of this, we know that cosine of 40 will end up being the same thing as sine. So cosine of 50, excuse me, will be the same thing as sine of 40. So take that, make that sine 40. And so now when we rewrite everything, this looks a little bit more like what we need to see. Okay, so from this point, we see that we have cosine A, cosine B minus sine A, sine B. And if we go back to looking at our particular formulas here, we'll see that the formula that best fits that is formula number 3, cosine of A plus B. So you see cosine of A plus B is cosine A, cosine B minus sine A, sine B. So now that we know that, what we can do is just write this as cosine of 80 degrees plus 40 degrees. And of course, we know that that is just equal to cosine of 120 degrees. So from this point, in order to figure out what cosine of 120 is, we know that 120 degrees is about right here with a reference angle of 60, and it's in quadrant number 2. So cosine is going to be negative. So this would be the same as saying minus cosine of 60 degrees. And so since we have 60 degrees here, this must be 30, and we're dealing with a 30, 60, 90 triangle. So the side opposite of 30 degrees is 1, side opposite of 60 degrees is square root of 2, and the side opposite of 90 is, the side opposite of 60 degrees is square root of 3, and the side opposite of 90 degrees is 2. And so we know cosine is just going to be the adjacent side of the angle, which is 1, to the hypotenuse, which is 2. So our final answer for this is a negative 1/2. All right, let's move on to the next example. So for our next example, we have cosine of 3 pi over 2 plus theta. And of course, just like we've seen before, we know that if we let 3 pi over 2 be A and theta be B, then we can write this as cosine of A times cosine of B minus sine of A, sine of B. And now we'll just fill in our angles. So cosine of 3 pi over 2, cosine of theta, minus sine of 3 pi over 2, and this would be sine of theta. And so, of course, since we don't know what theta is, we can't really simplify that, but we can work with the cosine of 3 pi over 2 and the sine of 3 pi over 2. Just in case you did not remember, 3 pi over 2 is equivalent to 270 degrees. And so if we do sine, we know that the quadrantal angles will start off being as such. Sine of 0 is 0, sine of 90 is 1, sine of 180 is 0, and sine of 270 is a negative 1. And so in noting that, we know that here sine of 3 pi over 2 is going to give us a negative 1 as a result. Similarly, for cosine, if we come here, we have cosine of 0 is 1, cosine of 90 degrees is 0, cosine of 180 is a negative 1, and cosine of 270 is 0. So all this just ends up being 0. And so now that we have that, this whole term goes to 0, and all we have left now is minus a negative 1, which is 1 times sine theta, which gives us our final answer of just sine theta. All right, so let's go ahead and move on to our third example. So our third example, we see that we're now dealing with a particular expression that has tangent in it. So if we go back and look at our formulas again, we'll see that this one sort of mimics tangent of a minus b the most. Excuse me. And so here we know that we have a problem because with tan of a minus b, right here where we see cotangent, we have tangent of some angle. And same thing here. So one of the things that we can do to try to help us out here is to see, all right, since we need tangent right here, is cotangent a cofunction of tangent? And so if we recall our identities here, and I'll just put here, note the following, that if we do cotangent of some angle theta, then that's the same as saying tangent of pi over 2 minus that angle. So here what this means for us is the following. We have cotangent of 7 pi over 15. That will be the same as tangent of pi over 2 minus 7 pi over 15. Okay? And so from here, we can deal with our angle. So I'll just go ahead and say equal and come here. This would be tangent of the LCD of these two fractions is 30. So pi over 2 is the same as 15 pi over 30 minus 7 pi over 15 is the same as 14 pi over 30. And of course, here we get tangent of 1 pi over 30. So everywhere where we see cotangent of 7 pi over 15, we can replace that with tangent of pi over 30. So here, tangent of pi over 30. And here, oops, can't do that because that's a different angle. So let's go ahead and figure out what cotangent of 3 pi over 10 is. So cotangent of 3 pi over 10 would be the same thing as tangent of pi over 2 minus theta, which in this case is 3 pi over 10. So if we keep on, we know that the common denominator in between 2 and 10 is 10. So we would have to say 5 pi over 10 here minus 3 pi over 10 here. And if we do that, that's 2 pi over 10, which gives us tan of pi over 5. So this is replaced with tangent of pi over 5. So now when we rewrite everything, this will look as tangent of pi over 5 minus tangent of pi over 30, all over 1 plus tangent of pi over 5 times tangent 30. And so that actually resembles the identity of tan of A plus B, where our A is pi over 5 and our B is pi over 30. So I'm going to say this is tangent of pi over 5. Excuse me, this is not plus, it's minus. So let me make that a minus instead of a plus. right, over 30. And so now if we subtract these together, common denominator between 5 and 30 is 30. So this would be 6 pi over 30 minus pi over 30, which will give us tangent of 5 pi over 30, which will give us tangent of pi over 6. Of course, I'll do some separation here. So, of course, tangent of pi over 6 is the same as a tangent of 30 degrees. And so we can use a right triangle to go ahead and figure out what that would be. If this is pi over 6, 30 degrees, then the angle here is pi over 3. And of course, this is a 30, 60, 90 triangle where we have 1, square root of 3, and 2. And so tangent will be the opposite side of the angle divided by the adjacent side. So this will be 1 over square root of 3. And so let me say that again because you didn't see that. So here's the right triangle that we can form. Since this pi over 6 is the same as 30 degrees, we know that this has to be pi over 3. And so the relationship 30 degrees 1, 60 degrees square root of 3, 90 degrees 2. And so opposite over adjacent is tangent of this particular angle. So we get 1 divided by square root of 3. And of course, if we want to rationalize the denominator, we would end up getting square root of 3 over 3. And so this would be our answer here. We'll move on to the next example. So for the next example, we see that we have sine of an angle, cosine of an angle. So we'll let that be A, let that be B. Plus, we see cosine of the same angle A, and then sine the negative of that angle. Well, one of the things that we know is that sine is an odd function. So this would be the same as a minus sine of pi over 4. Of course, there's our B. So this will change what we have going on here to sine of pi over 3, cosine of pi over 4, minus now cosine of pi over 3 times sine of pi over 4. Okay? And so with cosine, we know that the signs stay the same. So if we go back and refer to our formulas again, you'll see here that we need to go with formula number, yep, that's right, formula number 2. So here, this will all just be sine of pi over 3 minus sine of pi over 4. And so go ahead and put that there, sine of pi over 3 minus sine of pi over 4. And now we just need to get a common denominator for these fractions. Common denominator in between 3 and 4 is 12. So sine of pi over 3 will be the same as sine of 4 pi over 12. And sine of pi over 4 will be the same as, pi over 4 will be the same as 3 pi over 12. And of course, this just ends up being sine of pi over 12. And so from there, of course, this is the same as sine of 15 degrees. And we'll just keep it like this, because this is probably the simplest that we could do. Of course, we could have went ahead and figured out what the exact answer is, but for this one, our goal is to just figure out this in this form. If we wanted to figure out exactly what it was, of course, again, we could evaluate all these and figure out the actual answer. But here, if we use the trig functions and their particular addition formula, identities, this is what it would look like. Okay, so we have two more examples that we're going to do here. And how funny, this particular example here is finding the exact value for pi over 12. So what we're going to do is basically deconstruct what we just did and actually get the answer now. So one way we went forward, the other way, now we're going backwards. So for here, you see that sine of pi over 12, we need to figure out what this is. Now, of course, acting as if we did not know what was going on before, we know that pi over 12 here could be written as 12 pi over 12 minus 1 pi over 12. We could do that, but of course if we start to do all of this, then we're going to get into the whole name game of trying to figure out what's going to work. So an easier way to do this is for you to actually just figure out what pi over 12 is in terms of degrees, and then figure out the angle and radians that way. So we'll scratch this and just say pi over 12 times, and do the conversion, 180 over pi. And so that's 180 over 12, which is this times 10. And so 6 goes into 18 3 times, 6 goes into 12 2 times. So this will end up being 1.5 times 10, which is 15. So we knew that from last time. Now, 15 can be made up of either 30 degrees minus 15 degrees, or a better way for us to think about it is it could be 60 degrees minus 45 degrees. And so we're going to go with the 60 degrees minus 45 degrees because, of course, we can figure out what sine and cosine of 60 degrees and 45 degrees are. Okay, so what this means for us here is 60 degrees is the same as pi over 3, 45 degrees is the same as pi over 4. So that's how we ended up having pi over 3 minus pi over 4 last time. So now that we're at that point, we could say sine of pi over 12 is the same as sine of pi over 3 minus sine of pi over 4. And now we use our formulas, and I'll go back and show you that again. So we'll be doing formula number 2. So it'll be sine A cosine B minus cosine A sine B, where our A in this case is going to be pi over 3, B is going to be pi over 4. So sine A cosine B minus cosine A sine B. Okay, and so from this point, we know that we can just go ahead and figure out the remaining part of this problem. And let me move this up so that we can see it. Okay, so now, once we're here, we can go ahead and figure out what all these are. And I'm going to make these two nice right triangles to make it convenient for us. So we have a pi over 6, pi over 3. So this will be 1 square root of 3, 2. And we have pi over 4. Pi over 4, so pi over 4 is the same as 45 degrees. 90. So we have 1 square root of 2. So from here, we know that sine of pi over 3 is going to be, and here's our angle, sine is opposite over hypotenuse. So that's square root of 3 over 2. Cosine of pi over 4. This will be 1 over square root of 2 because here's our angle. We have adjacent over hypotenuse. Minus cosine of pi over 3. So for cosine pi over 3, we have pi over 3 again, and cosine of that is adjacent over hypotenuse, so that's 1/2. And then sine of pi over 4, again, it just will be 1 times square root of 2. And so now at this point, we just kind of combine everything together here. So we see our denominator both is 2 times square root of 2, so we can keep that the same. And our answer is square root of 3 minus 1 divided by 2 root 2. And of course, if I wanted to rationalize the denominator, I would multiply both numerator and denominator by square root of 2. And this will be square root of 2 times square root of 3 minus 1. And then, of course, square root of 2 times square root of 2 is 2. 2 times 2 is 4. So this would be our answer for this particular one. All right. And so now we'll move on to our last example. So last example says use trigonometric identities to find the exact value of the following expression. So cosine of negative 7 pi divided by 6. And so to start this one, the first thing that we note here is that cosine is an even function. So we know that this will be the same as cosine of 7 pi divided by 6. So that's the first thing that we know. So here, how do we deal with 7 pi over 6? Well, we know 7 pi over 6 is equal to 6 pi over 6 plus 1 pi over 6, which is the same as pi plus pi over 6. And both of those angles, we can find out what cosine, sine, and tangent are for that. So in this case, we're in good shape. So from here, we want to say that cosine of negative 7 pi over 6 is the same thing as saying cosine of pi plus pi over 6. And so now if we look at our formulas again, we'll see that we have cosine of a plus b, which is formula number 3. And so that would be cosine of a, cosine of b, minus, that is number 4, I believe. Cosine of a, no, I was correct. Cosine of a plus b is going to be cosine of a, cosine of b, minus sine a, sine b. So come back, we see that our a is pi, our b is that, and so I'll just write it with the a's and the b's to start off with. So cosine of a, cosine of b, and then we do minus sine a, sine b. And we'll go ahead and plug everything in now. Cosine of pi over 6, minus sine of pi over 6. Okay. And so now if we ask ourselves what is cosine of pi, again, from what we've talked about previously, we know that sine of pi is going to give us negative 1. We know that cosine of pi over 6, if we do that one, is going to give us square root of 3 over 2. If we do sine of pi, we know that that's going to give us 0. And sine of pi over 6 is going to give us 1/2. And so here, this just ends up giving us a negative square root of 3 over 2 as the answer. And so this concludes the examples for using the sine, cosine, and function addition formulas to simplify trigonometric expressions.